Hello my friend, welcome back to You Can Do TV channel. Felling a beech tree by dismantling is a specialized and hazardous task that requires a high level of skill in climbing, chainsaw operation, and controlled cutting. When a beech cannot be felled in one piece due to limited space or nearby structures, a sawyer must climb the tree and cut it down in sections, ensuring each piece falls or is lowered safely. This method demands expertise in tree climbing, rope work, and precision cutting techniques. The first essential skill is tree climbing using safety equipment. The sawyer must use climbing spikes, a flip line, and a harness to ascend and secure themselves at different heights, often between 30 and 100 feet, 9 to 30 meters. Beech trees have smooth, hard bark, which can make climbing more difficult and require careful rope anchoring. Techniques such as single rope and double rope climbing are crucial for mobility, stability, and fall prevention while maneuvering through the tree canopy. Chainsaw handling at heights requires precision and control. A sawyer typically uses a lightweight top-handle chainsaw designed for one-handed operation in confined spaces. Correct cutting techniques are critical to avoid kickback, which can be especially dangerous when the sawyer is in an unstable position. Making precise notches and back cuts ensures each section of the tree falls in the intended direction, reducing the risk of uncontrolled movement or damage to surroundings. Managing the descent of cut sections is vital for safety. Beech logs can be dense and heavy, with some sections weighing several hundred pounds. The sawyer must calculate the weight and trajectory of each piece before cutting. Rigging techniques using ropes, slings, and friction devices are often necessary to lower large sections safely, preventing them from crashing into buildings, power lines, or the sawyer's own climbing ropes. Poor execution can result in swinging sections, rope entanglement, or severe injuries. The most significant dangers of dismantling a beech tree include falls, chainsaw kickback, saw entanglement, and uncontrolled falling debris. OSHA regulations require sawyers working above 6 feet (1.8 meters) to use harnesses rated for 5,000 pounds tensile strength and a proper fall arrest system. The smooth bark of beech trees can also create a slipping hazard, making secure footing and proper rope work even more important. Additionally, sawyers are at risk of heat exhaustion, fatigue, and vibration-related injuries. Wearing cut-resistant pants, gloves, helmets, hearing protection, and eye protection is essential for reducing risks. Timber trucking in the Black Forest is a demanding yet rewarding profession, requiring skill, endurance, and a deep connection to nature. Owner-driver Dennis Piltz begins his workday at 4 a.m., transporting long log timber with his Scania R580 V8, outfitted with a Dahl superstructure and a self-steering trailer. This specialized setup allows him to haul logs up to 21.5 meters long, maneuvering through the forest's winding roads and tight spaces. Each day involves loading the truck, sometimes preloaded, sometimes requiring the use of an Epsilon crane, before setting off on long hauls across Germany. The challenging terrain demands precision, but the job comes with its rewards: the fresh scent of timber, the camaraderie among forestry workers, and the satisfaction of being one's own boss. As Dennis navigates the Black Forest's rugged landscape, every turn reminds him why he loves his job: the freedom, the adventure, and the connection to the land. For over 150 years, an oak tree stood tall in a woodland near Hungerford, its roots gripping deep into the soil, its branches stretching skyward. Season after season, it weathered storms, provided shelter to wildlife, and absorbed sunlight to fuel its slow, steady growth. Over time, however, the tree reached the end of its natural cycle. Identified as redundant by a woodland management company, it was selected for harvest, ensuring the sustainability of the surrounding forest. After being felled with care, the oak was transported to Deep in Wood, a sawmill located on a farm in Bezel, just outside Abington. This sawmill, known for its commitment to locally sourced and FSC-certified timber, received the massive log, ready to transform it into valuable materials. The journey to the sawmill marked a new phase in the oak's existence. Once cut, the boards were stacked and placed in a drying area, a crucial step to prevent warping and ensure stability. Air drying took several months, followed by kiln drying to achieve the right moisture content for furniture making and joinery. The lumber was then machined to precise specifications, ready to be shaped into new forms. Upon arrival, the tree was inspected for any hidden surprises, metal, embedded wires, or even glass bottles that had, in some cases, been absorbed into the wood over decades. Fortunately, this tree was free of such obstructions, making it ideal for processing. The log was carefully positioned and secured before being sawn into boards of varying thicknesses. The first cuts revealed the stunning grain within, patterns formed over a century and a half of slow growth. Each slice exposed the rich character of the oak, from tight growth rings to occasional knots that told the story of its long life. From there, the oak was distributed to various craftsmen, furniture makers, flooring specialists, and woodworkers, each imparting new purpose to the timber. The once living tree, which had stood for generations, would now endure for another century or more as furniture, beams, and handcrafted pieces, extending its life and legacy far beyond the forest floor. The log cutting machine simplifies firewood preparation by efficiently slicing logs into smaller pieces. It operates by securing the log in place and using a powerful rotating blade or chainsaw mechanism to make precise cuts. The machine ensures consistent log sizes, increasing productivity several times compared to manual cutting. Designed for ease of use and reliability, it minimizes physical strain and significantly saves time, making firewood processing faster and more efficient. The SpaltFix K-Vario firewood processor is a powerful and efficient solution for cutting and splitting logs into high-quality firewood. Designed for both mobile and stationary use, it can process logs up to 65 centimeters in diameter, or up to 70 centimeters for the latest models like the K700 and K710A Vario. Efficient processing. The machine integrates cutting, splitting, and loading in one seamless operation. A supercut saw unit with a 100 cm saw blade and a hydraulic double gripper ensures precise cuts, even for thick logs. Once cut, logs are automatically transferred to the splitting unit. Powerful splitting mechanism. Using up to 19 tons of splitting force, the system divides logs into billets with adjustable edge lengths, 5 to 15 centimeters, using an X-shaped splitting knife. The splitting process is fully automated, and users can control the log feed and cutting via joystick or remote control, depending on the model. Advanced automation and connectivity. The SpaltFix K710A Vario features a fully automatic feeding system, AutoFeed, allowing continuous operation for up to 1.5 hours without manual intervention. Additionally, the IIoT, Industrial Internet of Things, integration enables cloud-based data storage, software updates, and remote monitoring, enhancing productivity and customer support. Durability and user comfort. Equipped with oil coolers in both the saw and splitting units, the machine ensures reliable operation even in high temperatures. A chip extraction system and cleaning screen remove debris, maintaining a clean work environment. The unit can be transported and set up within 5 minutes, making it ideal for on-site firewood production. The SpaltFix K540 Multi is a high-performance firewood processor designed for efficient and seamless timber processing. It handles logs up to 55 centimeters in diameter and integrates cutting and splitting into a single work cycle. Equipped with a user-friendly two-hand joystick control on a well-structured panel, the machine ensures precise operation. A built-in log manipulator positions the timber correctly before processing, while the supercut harvester saw delivers fast and safe cutting with automatic chain and blade tensioning. The SpaltFix K540 Multi produces up to 18 uniform billets, each 50 centimeters long, in just one cycle without requiring a knife change. A hydraulic timber rocker facilitates smooth log transfer between the cutting and splitting areas, ensuring continuous operation with minimal interruptions. This results in higher output, trouble-free processing, and efficient firewood production. Whether stationary or mobile, the SpaltFix K540 Multi optimizes productivity and reliability in large-scale firewood processing. The LogCon Firewood line is an automated system designed for efficient firewood processing. It typically includes a log deck, saw, splitter, conveyor, and packaging system. The process begins with logs being fed onto the deck, where they are conveyed to a saw for cutting into predetermined lengths. The cut logs then move to a splitter, which splits them into firewood-sized pieces. These pieces are transported via conveyor belts for further processing, such as drying, bundling, or packaging. The LogCon Firewood line is designed for high efficiency, minimizing manual labor while maximizing output. Advanced models may include computerized controls for adjusting log sizes and optimizing production. This system is ideal for firewood suppliers looking to streamline operations, reduce waste, and increase productivity. The Sawmill sawing line incorporates advanced technology for high production efficiency, utilizing scanning, automatic optimization, and precision machinery. The process begins with log feeding, where logs are positioned and scanned to determine the optimal cutting pattern. This scanning process enables automatic optimization, ensuring maximum recovery of usable wood from each log. The sawing operation employs double chipper canters, quad and double vertical band saws, and resawing systems to process logs efficiently. The VTZ OptiFast system enhances productivity by allowing continuous feeding and precise blade positioning through 3D scanning. The sawing speed ranges from 15 to 70 meters per minute, depending on the specific equipment configuration. The saw blades used in this line vary in width and thickness, ensuring durability and precision. The wheels supporting the saw blades have diameters of 1,120 mm or 1,320 mm, depending on the model, and are driven by main motors with power capacities ranging from 22 kilowatts to 75 kilowatts. Once the logs are processed, cants are further refined using the RS1300 double-head resawing line, which features a full run-around system for continuous operation. The adjustable cant size feature, with brushless motor control, allows for flexible processing and improved efficiency. Automatic separation of boards ensures streamlined handling and further processing. The next stage in the process involves edging, where boards are trimmed for maximum utilization. The VRA40 of optimized edger is capable of processing up to 40 boards per minute, ensuring high throughput and precision in board dimensions. The automatic control system in the edger further enhances efficiency by reducing waste and optimizing the final dimensions of the boards. The entire sawing line is designed for both medium and high production ranges, accommodating different processing capacities up to 500 cubic meters of logs per 8-hour shift. Strong, precision-engineered frames ensure stability and durability, while brushless motors provide fast and accurate positioning to size. The control system offers different levels of automation, ranging from simple operation to fully automated systems with 3D scanning and optimization. Chipper canters play a crucial role in the initial breakdown of logs, efficiently removing bark and preparing logs for precise cutting. The double chipper canters BM600 provide effective log processing, reducing unnecessary material loss and improving overall yield. The outfeed system is fully automated with separation mechanisms to streamline handling and sorting of finished products. This ensures smooth transfer of processed wood to further production stages or storage, reducing downtime and manual handling requirements. With high-speed sawing, optimized scanning, and automated control, this sawing line maximizes efficiency and wood recovery. The combination of advanced machinery, automated systems, and precise blade positioning contributes to a highly productive and reliable sawing operation, making it an optimal solution for large-scale wood processing facilities. China is a global leader in the production of wooden coat hangers, supplying both domestic and international markets with high-quality products. The country's strong manufacturing infrastructure, skilled labor force, and access to raw materials make it a key player in this industry. Wooden hangers, known for their durability, aesthetic appeal, and premium quality, are widely used in luxury retail stores, hotels, and households. The global wooden hanger market is experiencing steady growth, driven by increasing consumer demand for durable and sustainable alternatives to plastic hangers. China contributes significantly to this growth, producing millions of wooden hangers annually for export to markets in North America, Europe, and Asia. As of 2023, the wooden hanger segment accounted for a significant portion of the $2.5 billion United States global hanger industry. The demand for high-end retail display solutions, particularly in the fashion industry, continues to drive sales of wooden hangers. China's wooden hanger industry primarily sources materials such as beech, lotus wood, maple, and cedar, which are valued for their strength and smooth finish. The production process includes several key steps: wood selection, cutting, shaping, sanding, polishing, lacquering, and assembling metal components such as hooks and clips. Many factories use advanced machinery to ensure precision, but handcrafted detailing is often involved to meet quality standards. Environmental concerns have led to the adoption of sustainable sourcing practices, with some manufacturers using FSC-certified Forest Stewardship Council wood to ensure responsible forestry management. Water-based paints and non-toxic coatings are also becoming standard to meet international environmental regulations. China exports millions of wooden hangers annually, with major buyers including the United States, Germany, the United Kingdom, and Japan. High demand from luxury fashion brands and hospitality sectors ensures a steady market for premium wooden hangers. However, the industry has faced trade challenges, such as anti-dumping duties imposed by the U.S. on Chinese hangers in 2008, which affected export prices and competitiveness. Despite these hurdles, Chinese manufacturers continue to adapt by improving quality and seeking alternative markets. The production of wooden kitchenware at Wood Acacia Wood Kitchenware Factory follows a process combining skilled craftsmanship and advanced technology. High-quality wood, such as acacia, rubberwood, oak, and walnut, is carefully selected and treated to ensure durability. Experienced artisans, with over 30 years of expertise, shape and assemble products with precision. For intricate designs and branding, CNC-controlled engraving machines are utilized to achieve high accuracy. Each product undergoes rigorous quality control and testing to meet export standards. The factory offers customization options, including engraved logos and bespoke designs, catering to businesses, hotels, restaurants, and individual buyers. From cutting boards and serving trays to wooden furniture, the production process ensures a balance of traditional woodworking techniques and modern innovation, resulting in premium quality kitchenware and home accessories. The wooden cable drum production industry in Indonesia is an integral component of the nation's wood manufacturing sector, serving the needs of various industries such as telecommunications, construction, and energy. Wooden cable drums are essential for transporting and storing cables, offering durability and cost-effectiveness. In 2024, the Indonesian market for wood boxes, crates, and cable drums was valued at approximately $203 million, reflecting a steady growth trend over the past decade. From 2012 to 2024, the market experienced an average annual growth rate of 5.4%, indicating a robust demand for these products. Indonesia's wood manufacturing industry has been on an upward trajectory. The value added from wood manufacturing was projected to increase by 10.05% between 2025 and 2029, amounting to an increment of $0.2 billion. This growth is attributed to the country's abundant timber resources and advancements in wood processing technologies, enabling the production of high-quality wooden products, including cable drums. The export landscape for wood boxes, crates, and cable drums has seen fluctuations. In 2024, Indonesia exported 49,000 units of these products, marking a significant decrease of 18.6% from the previous year. This decline underscores the challenges faced in the export sector, possibly due to increased domestic demand or global market shifts. The wooden cable drum industry encounters challenges such as raw material availability and price volatility. However, there are notable opportunities, particularly in the development of eco-friendly and sustainable cable drums. Aligning with global sustainability trends, Indonesian manufacturers are exploring the use of recycled and biodegradable materials in production processes. The demand for wooden cable drums in Indonesia is anticipated to remain strong, driven by infrastructure development and industrial expansion. The global cable drum market is projected to grow, with the wood segment expected to exhibit a compound annual growth rate of 3.2% over the forecast period. The production of industrial Barecore involves several key stages: log selection and cutting. Raw materials for industrial Barecore typically come from fast-growing plantation species such as rubberwood, acacia, and albizia. These logs are selected based on their density, straightness, and moisture content. After selection, the logs are cut into small strips, usually with a thickness of 10 to 15 millimeters and a width of 30 to 50 millimeters, to create uniform blocks. Drying and moisture control. The cut wood strips are dried using kiln drying or air drying methods to reduce their moisture content to 8 to 12%. Proper drying is crucial to prevent warping, cracking, and moisture-related defects in the final product. Indonesia is one of the leading producers of industrial Barecore, thanks to its vast plantation forests and established wood processing industry. The sector plays a crucial role in plywood and furniture production, supplying both domestic and export markets. Glue application and pressing. Dried wood strips are arranged and glued together using adhesives such as urea formaldehyde, UF, or phenol formaldehyde, PF. These blocks are then pressed using cold press or hot press machines at high pressure to ensure strong bonding. While specific data on industrial Barecore production is limited, its connection to the plywood sector provides useful insights. In 2022, Indonesia produced approximately 4.9 million cubic meters of plywood, with a significant portion utilizing industrial Barecore as a core material. Indonesia's wood processing industry is a major contributor to its economy, leveraging abundant forest resources to produce high-quality wood products. One of the key segments within this industry is industrial Barecore production, an essential intermediate product used in furniture, plywood, and interior applications. This industry has experienced steady growth due to increasing domestic and international demand. In terms of exports, Indonesia exported plywood worth $1.26 billion in 2023, with key markets including Japan, $434 million, the US, $353 million, and South Korea, $213 million. This suggests a strong demand for Barecore as a critical raw material. Trimming and sanding. Once pressed, the Barecore panels are trimmed to standard sizes, commonly 1,220 mm by 2,440 mm. After trimming, they are sanded to achieve a smooth and even surface, preparing them for further lamination or direct use in plywood production. With rapid urbanization and infrastructure development, Indonesia's domestic furniture and construction industries have fueled demand for industrial Barecore. The rise of modular furniture production has also increased the need for high-quality engineered wood products. Despite its growth, the industry faces challenges related to deforestation and sustainability concerns. Indonesia has implemented the Timber Legality Assurance System to ensure that all wood products, including industrial Barecore, come from legal and sustainably managed forests. The future of Indonesia's industrial Barecore industry looks promising due to technological advancements. Investments in automated processing and glue technology are improving production efficiency and product quality. Sustainable practices, certification initiatives, and responsible forest management are strengthening Indonesia's position in eco-conscious markets. Quality inspection and packing. Before shipping, the Barecore panels undergo a strict quality inspection to check for defects such as delamination, uneven thickness, or moisture inconsistencies. The finished products are then packed and distributed to manufacturers for further processing. The Netherlands has a rich and storied history in wooden shipbuilding, dating back to the 16th and 17th centuries when the Dutch Golden Age saw an unparalleled expansion in maritime trade. At its peak, the Netherlands was producing over 700 ships per year, supplying a global fleet that made the Dutch Republic one of the most dominant naval and trading powers in the world. The construction of Nyala. Commissioned in 2018, Nyala was built as a faithful yet improved recreation of Impala, 1954, an earlier Olin Stevens yawl. Stevens yawl designs are legendary, tracing their lineage back to Durrad, 1930, which remains one of the most successful racing yachts in history. With Nyala, the goal was to create a yacht that retained the aesthetic beauty and seaworthiness of its predecessors while incorporating modern advancements for superior performance and ease of handling. Today, while modern materials like fiberglass and aluminum have largely supplanted traditional wood, Dutch craftsmanship in wooden shipbuilding remains highly regarded. One of the premier wooden boat builders in the Netherlands is Venty's Scheepstimmerwerk, based in Enkhuizen, a town with a centuries-old shipbuilding tradition. Venty's specializes in high-quality wooden yacht construction, and among their notable projects is the Nyala, a stunning Bermudan yawl designed by Sparkman and Stevens. Nyala's hull is a wood core composite, a technique that combines the elegance and flexibility of traditional wooden construction with the strength and durability of modern composite materials. This construction method results in a vessel that is lighter and faster than its predecessors while still maintaining the classic wooden yacht appearance. Specifications of Nyala. Nyala measures 17.00 meters in length overall, with a beam of 3.81 meters, giving her a sleek and efficient profile on the water. Her draft of 2.40 meters allows her to handle both deep and coastal waters with stability and precision. She carries a sail area of 141.3 square meters, ensuring powerful yet manageable sailing performance. Designed by Sparkman and Stevens, one of the most revered names in yacht design, and launched in 2018, Nyala exemplifies the fusion of classic aesthetics with modern advancements in yacht construction. Nyala was designed for fast transatlantic passages, allowing her owner to sail effortlessly between Europe and the Americas. The carefully crafted hull and rigging ensure a balance between speed and comfort, making her not only a capable cruiser but also a formidable performer in ocean racing conditions. Dutch shipbuilding expertise. Venti's sheepstimmerwork represents the continuation of Dutch wooden boat-building expertise, with skilled craftsmen who utilize both traditional techniques and modern innovations. The company's work on Nyala reflects the broader Dutch commitment to maintaining a legacy of high-quality shipbuilding. The Netherlands remains a hub for custom-built wooden and classic yachts, attracting owners who value precision craftsmanship and maritime heritage. While wooden shipbuilding is no longer the primary industry it once was, the Dutch still build some of the finest wooden yachts in the world. With projects like Nyala, the industry showcases its ability to blend tradition with innovation, proving that classic wooden yachts can still compete at the highest level of design and performance. The production process of Andrew wooden cable reels and plywood reels begins with the selection and procurement of raw materials, including high-quality timber and plywood sourced from certified suppliers. Once cut, the wooden components are treated and assembled. The flanges are crafted with precise drilling and reinforcement to ensure durability. The barrel, which forms the central core, is constructed with precision to withstand the weight and tension of cables. The raw materials undergo precision cutting and shaping using advanced machinery to achieve the required dimensions for the drum components, including flanges, barrels, and cores. High-strength adhesives and mechanical fasteners are used to secure the assembly, ensuring stability and longevity. After assembly, the reels undergo a thorough quality control process. Each unit is inspected for structural integrity, dimensional accuracy, and compliance with industry standards. Protective coatings and treatments may be applied to enhance durability and resistance to environmental factors. The final stage involves packaging and logistics optimization. Finished reels are carefully stacked, labeled, and prepared for shipment. The XYLOCHIP 200T wood chipper is a high-performance machine designed for agricultural and forestry applications. It is adapted for tractors with a 3-point linkage and operates within a power range of 75 HP to 150 HP. Driven by a PTO shaft with a slipping clutch at 1,000 revolutions per minute, it ensures efficient wood processing while maintaining safety. Equipped with a versatile 5-in-1-inch rotor system, the chipper offers 3 standard configurations: 2 knives, 2 rows of hammers, or a combination of knives and hammers. Additionally, 2 optional configurations allow for 1 knife or 4 rows of hammers, providing flexibility in processing different types of wood. The machine features an extra-wide feeding hopper with a safety bar to prevent accidental engagement. The NOSTRESS regulation system offers 3 operating modes: ECO, Medium, and Max, allowing users to control feed speed based on workload. A swiveling blower with a 360 degrees adjustable cap ensures precise chip discharge. The feeding roller's speed can be adjusted hydraulically to control chip size. Designed for easy transport, the hopper folds using a mechanical winch. The Urban TR75 mini tractor chipper operates efficiently by utilizing a pre-built drive system, making it compatible with both small and powerful tractors. The machine is mounted on the tractor's 3-point hitch and is powered through the PTO shaft. Its design ensures smooth operation, even when connected to tractors with as little as 15 horsepower, while optimal performance is achieved with 25 horsepower or more. The chipper features a V-belt drive, which plays a crucial role in shock absorption and overload protection. This eliminates the need for an additional overload clutch. The large 90 kilograms pulley serves as a flywheel, further reducing shocks and ensuring a consistent and stable chipping process. The machine's cardan torque is reduced by half compared to the chipper while maintaining the same processing capability for branches up to 80 millimeters in diameter. Once the tractor's PTO engages, the belt drive transfers power to the chipping mechanism. The rotating blades efficiently process branches into uniform wood chips. The machine's design ensures smooth and continuous operation, reducing strain on both the chipper and the tractor. This setup allows the TR75 to be used effectively even with low-power tractors, making it an ideal choice for small-scale forestry and agricultural applications. The Pezzolato PTH1000 chippers are designed to process large volumes of wood material efficiently and precisely. Their operation is based on an advanced cutting system that ensures a constant production of high-quality wood chips. The process begins with the introduction of the material into the 1,000 mm wide inlet, allowing the processing of logs up to 800 mm in diameter. The material is conveyed towards the chipper drum, which, with its 1,000 mm diameter, ensures a high processing capacity. The drum, equipped with knives and arranged in staggered sections, cuts the wood with precision, while the counterknife and the interchangeable calibration grid guarantee a uniform chip size. A key feature is the drop-down counterknife system, which minimizes damage caused by the accidental entry of foreign objects. After cutting, the wood chips pass through the calibration grid and are conveyed to the rubber discharge belt for final transport. This model is equipped with a standalone Volvo Penta TAD 1672 engine with 700 HP and mounted on a Triton trailer, but different configurations and accessories are available to meet specific operational needs. The WRAVOR WRC 1250 horizontal band sawmill is designed for high productivity in industrial sawmilling operations. The cutting process begins with log placement onto the sawmill bed, where the log is secured using reinforced supports and extra grip clamps. The movable log turners enable smooth positioning and rotation of logs, ensuring optimal alignment before cutting. Strong rails, reinforced with weld-hardened material, provide a stable base for the log, reducing vibrations and enhancing cutting precision. It incorporates advanced engineering solutions, hydraulic functions, and automated features to enhance efficiency while reducing labor requirements. The sawmill operates through a sequence of precise, automated, and manually controlled processes that ensure accurate and high-speed log processing. The cutting process is continuously controlled through video monitoring and eye visualization systems, ensuring real-time tracking and adjustments. The bandsaw blade, measuring 9,045 mm in length and 160 mm in width, moves along the guided track, slicing through the log with high precision. A precutter follows the log's shape, allowing for an optimized initial cut that minimizes waste and maximizes yield. The maximum log diameter that can be processed is approximately 1,250 mm, with a cutting thickness of up to 340 mm per board. The WRC 1250 offers both manual and automatic cutting modes. In automatic mode, the sawmill utilizes a computer-controlled system to adjust the blade position, cutting angles, and feed speed for consistent results. The hydraulic system allows for quick log maneuvering, increasing operational efficiency. Each roller on the sawmill bed is height adjustable and driven, facilitating smooth material handling throughout the process. Once the initial cutting phase is complete, the processed boards and prisms are automatically sorted and directed for further refinement. The crosscut saw Type 800A, an electro-pneumatic system, ensures clean and precise cross-cutting of boards. The multi-rip saw Type 750, 20-120, is used for making prisms, cutting thin lamellas, and ensuring uniform board thickness. Boards are efficiently pushed forward for additional processing, while thin lamellas and secondary cuts are redirected back for further refinement. The sawmill's motor operates with an electric mechanical brake and frequency inverter, offering power options of 45 kilowatts to 55 kilowatts. The system's elevation capacity reaches up to 1,150 millimeters, ensuring flexibility in cutting height adjustments. With a cutting capacity of up to 55 cubic meters per 8-hour shift, the WRC 1250 maximizes throughput while maintaining high precision. Dibble Firewood Processor utilizes a custom-built firewood processor instead of traditional axes or small splitters. This specialized machine efficiently cuts and splits logs, ensuring high-quality firewood production. To eliminate unwanted debris such as small wood pieces, bark, and dirt, a homemade wood tumbler is used. This process results in cleaner, premium firewood, while the discarded material is repurposed into kindling and sold to local campgrounds. To maintain optimal burning quality, the firewood is stored in a dedicated indoor facility, preventing moisture exposure and ensuring a consistently dry product.